Right, so this is question 4.7 and it's about using a scale diagram. So for that, I'm going to need some squared paper. I'm going to need a ruler, a protractor, pencils, and probably a rubber, because I'm probably going to make some mistakes, but that's what we're going to need for this. So move all that out of the way. Using a scale diagram, calculate the resultant force acting on a boat when an easterly wind provides 2,500 newtons of force. The tide provides 1.2 thousand newtons of force from the direction 30 degrees more northerly than the wind, and give your answer to 2 sig fig. Okay, so let's have north in this direction here. So that's north. So whenever we're taking bearings, we always measure from north. So to measure a bearing, you would basically pop your protractor along the north, and then this direction is 040, this is 090, this is 180. This is 180 plus whatever these numbers are. So here, even though it says 90 on the protractor, this is a bearing of 180 plus 90, that's 270. And just to give you another few examples, that direction there, which is northwest, is a bearing of 315. So you would say 315. So the question says, use a scale diagram. Resultant force on a sailing boat when an easterly wind provides 2.5 kilonewtons of force. So easterly wind means it's coming from the east. So that means that the direction of the wind is from the east, so it's blowing in this direction. So let's pop the boat just there. So that tiny little dot there that you might not be able to see, I'll circle it. That little dot there, that's the boat. And so I'm going to have an easterly wind of 2.5 kilonewtons. Now, I need to choose an appropriate scale here. So what's the other size of the force? 1.2 kilonewtons. So I've got to choose a decent scale here. So I've got 2.5 kilonewtons and 1.2 kilonewtons. So let's have, I don't know, let's let 10 centimeters equal 2.5 kilonewtons. So that means 1 centimeter is going to equal 1/10 of this, which is 250 newtons. So if we were taking it down even further, 1 millimeter is 25 newtons. So all I'm doing there is that's the scale that I've chosen, and these are how those things scale down to 1 centimeter and 1 millimeter. So I now need to draw a force which is 2.5 kilonewtons, that's 10 centimeters, and it will be in, oh my goodness, I'm running out of paper. That was lucky. Wow. Am I gonna... I've not got enough room. I'm gonna have to put my boat here. So I told you I'd make some mistakes, that's normal. So I have to rub that out. So 10 centimeters, that is from this point here to this point here. And I need a nice clean line. So that is the direction of the wind, and I'm going to label that 2.5 kilonewtons. Okay, the tide provides 1.2 kilonewtons of force from a direction which is 30 degrees more northerly than the wind. So what that actually means, I'll just go to the smaller ruler here. What that means is the direction of the tide is from a more northerly direction. So this is from the east, and this is a direction that's more northerly than east. So anything in this direction here is more northerly than the direction of the wind, but this is only 1.2 kilonewtons of force. So 1.2 kilonewtons of force, that's 1,200 newtons, and we've got 25 newtons is 1 mil. So if I do the division, how many 25s go into that? So 1,200 over 25 is 48 millimeters. So it's 48 millimeters, and so the wind is going to, the tide, I beg your pardon, is going to come from not this direction, but a direction that's 30 degrees more like this. So if I pop that there. 30 degrees is just here. So I now need to draw a line which is 48 millimeters long and which is in that direction. So pencil to paper, just double check. Right, now that's on 23. So I need to go 48 mil. So that's 10, 20, 30, 48 millimeters is just there. So that is 1.2 kilonewtons. Right, the question says, calculate the resultant force. Okay, so what I've got to do now is I've got to add these two things together, and the way that you add these two things together is by using the parallelogram of forces rule. And remember, we've done this in lesson, and so I need to basically construct this parallelogram like so, and then where these kind of lines meet at somewhere over here is going to be the resultant force, and then I'll draw the resultant in just there. So let's do that. I basically need to add a 10 centimeter line onto this one, and it's got to be from the east, so it's got to be parallel with all these grid lines on here. So let me just move my little thingy out of the way a little bit. So this needs to be 10 centimeters long, so that's bang on 10. Let's pop the pencil on the dot. That is bang on 10 now. Is that parallel? Not quite. That's parallel. Just check it again. And then draw from here to here. At that point there. That point just there. So here's my 10 centimeter line. And this point here is the resultant. So I'm going to leave the pencil there. Just check that's in the right place. It was. So here, that point there is the resultant of those two. And the question says, just calculate the size of the force. Okay, so we measure the length of that line. Can you see what I'm doing? I don't know. I've made this little rig out of Lego to help. That line is 14.123 and a bit. So it's 14.3 and a bit centimeters, which is 143 millimeters. And 143 millimeters is 143 of them. So 143 times 25 is equal to, oh gosh, so what am I doing here? By 4. Let's get the calculator out. Oops. So 143 times 25 equals 3,575 newtons. Okay, that's my answer. But the question asks 2 sig fig. So to 2 sig fig, it's 3, and then that takes that to 6. So it's 3,600 newtons, or 3.6 kilonewtons. And if I just pop this out, how do I get this out? If I pop that out, that's the correct answer, 3.6 kilonewtons.